All right, so today we are looking at multiplying binomials a little bit more. Well, multiplying polynomials, and specifically we're going to start with multiplying binomials. The way we multiply binomials is just by using the distributive property to multiply. Um, so there's one of two ways you can sort of think of it. There's an acronym that we use. It is FOIL. And what FOIL tells me is the order to multiply. So F is for first, O is for outer, I is for inner, and L is for last. And it just tells me which terms to multiply with which to make sure I'm getting them all done. So I'm going to show you one of two ways to multiply these together. So I'm going to start with FOIL. And what FOIL tells me is I'm going to multiply the first terms from each binomial together. So that would be 2x times x, which is 2x squared. Outer tells me the outer terms. So this is the outer term and this is my outer term. So 2x plus 4 or times 4 would be 8x. Now my inner term, so the inside would be 3 times x, which is just 3x. And then my last terms, which will be 3 times 4, which is 12. And then I need to make sure I don't have any like terms. So I have 2x squared, and then 8x plus 3x. Those are like terms, and then plus 12. So this would be 2x squared plus 11x plus 12. So that's FOIL. You can also just straight up use the distributive property. And so looking at this next example, if you want to do it by FOIL, go ahead and try that. But I'm going to just do this by distributive property. And the way you do that is I'm taking my first term and I'm distributing it into that second parentheses. So I'm not multiplying 6y plus 7, right? Because those are being added. I'm multiplying 6y times 2y, which will give me 12y squared. And then I'm multiplying 6y times 3, which is 18y. So this is still first term and then outer terms. And then I'm going to do the same thing. I'm going to take 7 and distribute it to each term. So 7 times 2y, that's 14y. 7 times 3, that's 21. So the main thing with this is just making sure that each term in that first binomial gets multiplied to each term in the second binomial. So again, here I need to see if I have any like terms. So I have 12y squared, 18y plus 14y, that's going to be 32y, and then plus 21. Okay. Let's do one more of these together. If you want to think of it as FOIL, or if you want to think of it as just distributing each term out, you still end up doing the same thing no matter what. So I'm going to start multiplying 3x times 2x. So those are my first terms. So that's 6x squared. And then multiplying 3x times 5. Those are my outer terms. So that will be plus 15x. And then, so that's 3x being distributed to both things. And then I'll have 4 being distributed to 2x. So that's plus 8x. And then 4 times 5, which is 20. So then combining like terms, I get 6x squared plus 23x plus 20. So go ahead and do those next two examples. And again, you can check your work with the key on bright space. All right, let's go ahead and look at this example right here, this 2x minus 3 times 4x squared minus x minus 3. So the concept of FOIL kinds of falls apart when we get to multiplying. This is a binomial times a trinomial, right? So this is where the distributive property makes a little bit more sense to use. So again, we're going to do that same thing where I take this first term and I'm going to multiply it to every single term in the second set of parentheses. So what that will be, we get 2x times 4x squared. That's 8x cubed. Then I have 2x times negative x, which is negative 2x squared. And then I have 2x times negative 3, which will be negative 6x. So that's my first term done. Now I'm going to distribute out negative 3 to each term in my trinomial. So negative 3 times 4x squared, that's negative 12x squared. Negative 3 times negative x is a positive 3x. And then negative 3 times negative 3 is a positive 9. So I need to look now for like terms. 8x cubed does not have a like term. Negative 2x squared has negative 12x squared. So that's going to give me negative 14x squared. Negative 6x has 3x. So negative 6x plus 3x will be negative 3x. And then I just have my plus 9 by itself. Okay, go ahead and try this next one. You can think of it, one, as distributing each of these terms to each of these two terms, right? Or you can think of it the opposite way, because that kind of looks like a mess. This is the same thing as n plus 1 times 2n squared minus n minus 6. These are the same thing. And I think I like multiplying it more this way, so I don't have as many things going on. So go ahead and try that and check your answer with the key in bright space. Okay. So next thing we're going to do is making those algebraic and geometric connections again. So we want to find the area of a shaded region. So to find the area of a shaded region, we're going to find the area of the entire figure and subtract the area of the whole. So first, I want to think about what is the area of a rectangle. Area, remember, area is length times width of a rectangle, and then area of a triangle is 1/2 the base times the height. So this is what we are using in both of these problems. So first, I've got to find the area of the entire figure. And then we're going to subtract the area of the whole. Okay? So this is sort of combining what we did today with what we did last class. So area of the entire figure, I have x plus 4 times x plus 2. So that's my length times my width. So x plus 4 times x plus 2 minus, I have x times x minus 2. So let's first start with this one. I'm going to distribute out this x to x and x plus 2. So x times x is x squared. X times 2 is 2x. And then this 4. 4 times x is 4x. 4 times 2 is 8. And then here I have a monomial, negative x, and that's being distributed out to the x minus 2. So negative x times x is negative x squared. And then negative x times negative 2 is a positive 2x. So then I'm just combining like terms. X squared and x squared are like terms. So I have x squared minus x squared, which is just 0. So that term goes away. I have 2x plus 4x plus 2x. So 2 plus 4 times 2, that gives me 8x. And then I'm left with this plus 8 right here. So that would be my solution. So go ahead and try the next one. Remember to use the area of the triangle, the 1/2 base times height. Check your solution on bright space. And then what you are going to do is this next page, this multiplying special cases investigation. You know how to do this. You know how to multiply those binomials. So I want you to go through this page, and I want you to think about what patterns are you noticing, things like that, and this page as well. Check your answer on Brightspace. After you are done with that, you can go ahead to the next video where we are going to get into the multiplying special cases. But do the investigation first on your own.